So in this video, we're going to be talking about how to find the graph of a logarithm, but you can't talk about graph of logarithms without first reviewing exponential graphs. So if you already know how to do the exponential, you can fast forward to where I do the logarithm, but I wouldn't recommend it unless it's something you just reviewed so that we could talk about how this even comes about. So quick review. To do this, the key points are focused around the origin. So you would have -1, 0, and 1. 2 to the -1 would be a half. 2 to the 0 would be 1. Anything to the 0 is 1, including something like e, which we'll talk about later. And then 1 would give you the base back. So once you have that, you're going to make this graph. The graph kind of looks like a slide, if you can remember. So at -1, you would be at half. At 0, you'd be at 1. And then at 1, you would be at 2. And there's this thing called an asymptote going across the x-axis to give you the graph. And that graph looks like this. So an important little reminder of the key concepts here is that this has a horizontal asymptote at y equals 0. It has a y-intercept at 0, 1, an x-intercept of none, because clearly there's an asymptote blocking that. The domain is -infinity to infinity. The range is 0 to infinity. Remember, domain is -infinity to infinity, but the range, there's nothing down here, so it goes from 0 to infinity. And then the end behavior is the domain, which is -infinity to infinity, and then a description of what's happening in the range. So at -infinity, it's going to the asymptote or 0. So it goes to 0. So just be an arrow there. And then at infinity, the graph is going up to infinity. So now, what is a logarithm? Again, the logarithm is the inverse of this. And the word inverse means in mathematics, I take the entire domain and I replace it with the range and vice versa in coordinated pairs, meaning this -1, 1/2 you see right here. So what goes with it? A half, right? And then the 0 goes with 1. So down here it would be 1, 0. I'm replacing the domain with the range. And then here this 1, 2 would be 2, 1. Now, if you had additional things, remember that the logarithm was an exponent, so you would really be raising 2 to the -2, which would be a fourth. And this would be 2 to the 2 or 4. But we are only going to focus on these three values. It's just showing you that that pattern repeats. That's what you need to worry about in this class and most classes, I would assume. So let's take a look at what happens when I look at those points, right? At 1/2 -1, I'd have a dot there. I'd have an x-intercept now, and then 2, 1. So it doesn't just inverse the coordinate pairs for the key points. It inverses everything, meaning this asymptote that was originally a horizontal asymptote, it's now going to be a vertical asymptote. This is where that mnemonic device called Hoybux really comes into handy. Horizontal are y's with a slope of 0, and verticals are x's with a slope of undefined. So our vertical asymptote, instead of being y equals 0, is now x equals 0. And these two also inverse. So like the x-intercept and the y-intercept will reverse, meaning there is no y-intercept. When you draw the graph, you can see that in this case, the asymptote is blocking the y-axis, making this none. And the x-intercept is now 1, 0. So not only did it inverse the y to an x-intercept, but it also inversed these. See how it's 1, 0 instead of 0, 1. The domain is now going to be the range. And you can see that very clearly. The domain now starts at 0, right? It starts at 0 and goes to infinity. And then the range is now going from -infinity to infinity. So even the domain and range inverse. Okay. And so it even inverses the end behavior. Remember, the end behavior is the domain, right? So the end behavior is the domain values of 0 to infinity, and then the coordinating values of the range. So at 0, the graph is going to -infinity. Oop, got to put the y goes to. Give me 1 second. So y would go to -infinity. And at infinity, the graph's going up to infinity. So it's the same thing, only different, right? And this all starts with these key points reversing. So the key points for this particular graph would be 1/2, -1, 1, 0, 2, 1. But in general, they would be 1 over b, 1, always 1, by the way, and then b. But specifically for this graph, they are those things. So we can just write that down again here. Okay, if you want to go back and make these specific to the graph, you can. It's up to you, however you want to take your notes. So down here, we just want to look at those key points because they're the reason all this this inversing is happening. So over here on this one, this 3 is the base, and so this will be a third, and this will be 3, and this one's always 1. Some students like to start with just knowing that that's going to be 1. So here for this one, this 1/2, remember negative in the world of exponents and in the world of logarithms means reciprocate. So that's 2/1. And 1 in the world of exponents and logarithms means write down the same thing. So over here, this -1, remember, reciprocate that. Doesn't mean make a fraction, it means reciprocate, so it'll be 3. And this 1 will now mean write down the base. So watch out for the inverse. We did separate it into a new chapter to help you with that, but they are very connected. And we'll look at transformations of this and ease and all that in the next following videos.